The last video of this module is going to review the formation of covalent bonds and how reactive atoms can come together and share electrons to fill their valence shell. And again, you have read the written description of covalent bond formation, just like you did for ionic bonds, but I do believe that it is important to have a visual of how these bonds come together. So we're just going to start with the simple molecule, and we're going to look at H2 as an example. H2 represents the molecular formula, and the molecular formula tells you what atoms and how many of those atoms are present in the molecule. So for H2, which is molecular hydrogen, we have 2 hydrogen atoms. And again, very similar to what I said in the ionic bond video, you may be given a molecular formula and not know exactly how these atoms are associated by what type of chemical bond, and that's okay. Again, you can use the tools that you have in the electron configurations and looking to fill the valence shell, that octet role, to determine how these atoms will interact. So let's start by drawing 2 hydrogen atoms, and we're drawing them in their electron configuration. So each of these hydrogen atoms has 1 electron, and again, I'm just going to focus on the electrons in these atoms, not so much the proton that is in the atomic nucleus. And then I'm going to take actually another color and draw the other hydrogen atom that is part of this molecule. And again, fill that 1 electron position for its 1 valence shell. Now, as we look at both of these hydrogen atoms in their electron configuration, you can see that they're both reactive. They do not have a filled valence shell. You could also see that both hydrogen atoms require 1 electron to fill their valence shell. And in this case, these 2 hydrogen atoms will come together and share the pair, the black and the blue, that pair of electrons that they have between them. And I'm just going to shift the orientation of the electron configuration so we can see these hydrogen atoms come together and form that covalent bond. So this is one of the hydrogen atoms that I'm going to show here in black. On the other side, I'm going to do the hydrogen atom in blue, and it's going to bring in its 1 electron. And then I'm going to show the sharing of these electrons by overlapping their valence shells. So you can see this overlap here, right? This region right here represents a shared pair of electrons. And this shared pair of electrons is a covalent bond. So when atoms come together and share pairs of electrons, they form the strong covalent bond, which is one type of chemical bond. We can also write the H2 molecule in its structural formula, and that is association of those 2 hydrogens by this line. And again, this line represents a covalent bond. So whether you see it in the line form here or you see it in the electron configuration, these 2 designations are equivalent. Basically what we're saying are these 2 atoms are held together by a sharing of a pair of electrons, which represents a covalent bond. And you can see with the H2 molecule that this sharing of this 1 pair of electrons to create this single covalent bond fulfills the goal of each of these 2 hydrogen atoms, both the blue and the black, of filling their valence shell. Let's look at another molecule here. We'll use the same approach. And this time what we'll look at is CH4, methane. Okay. Again, if you're given this molecular formula or any molecular formula, the best approach to take is really draw out the electron configuration for all the atoms involved. So I'm going to start with a central carbon, and I'm going to draw its electron configuration. Carbon has an atomic number of 6, so it has 2 electrons in its inner shell, and then the other 4 electrons we are going to place in the outermost shell, that valence shell. So I'm going to finish putting these electrons in pairs around that carbon atom. And then we're going to fill in one of the pair until we have reached the 6 electrons that carbon has in their positioning in that carbon atom. So this is your typical electron configuration for carbon. And if I just draw, well, I don't even think we have to redraw one for hydrogen, right? Because we have seen the electron configuration of hydrogen even up above. Each hydrogen atom is going to have 1 electron. And in the case of CH4, we have 4 hydrogen atoms. So each of these 4 hydrogen atoms is going to come in and share a pair of electrons with carbon to fill their valence shells. Now, this hydrogen atom has a filled valence shell, but carbon is still reactive. But we have 3 more hydrogen atoms to place. They are all going to share a pair of electrons with carbon, again showing that sharing with that overlapping shell. And a lot of times using different colors to represent the various atoms also helps in drawing the electron configuration of the molecule to confirm whether this can be a share or not. Again, we can represent this in its structural formula. When we look at this methane molecule, all atoms have fulfilled their goal of filling their valence shell, and this molecule is stable. Now there's a hint I can give you to determine how many covalent bonds an atom can make. And to work through this little tip or hint, let's use water. Water is made up of 2 hydrogen atoms and 1 oxygen atom. I'm going to draw out the electron configuration for oxygen in black. Oxygen has 8 electrons based on the atomic number for oxygen. We have 2 in the inner shell, and then I'm going to draw that second shell with 8 electron positions and then fill in based on the kind of the process that we've talked about previously. So electron number 3, 4, 5, 6, 7, and 8. Okay. And when you look at the valence shell, you can see that oxygen has 2 unoccupied electron positions. And the number of unoccupied electron positions equals the number of covalent bonds that can be formed by that atom. So oxygen can form 2 covalent bonds. The hydrogen atoms that are in water, each one of them has 1 unoccupied position in its valence shell and can form 1 covalent bond. If we place these hydrogen atoms and share pairs of electrons with that oxygen atom, we have constructed the electron configuration for water. Again, we can show this as a structural formula, and here you can see that oxygen can make 2 covalent bonds, both of them being to water. Both of them being to hydrogen. And both of the hydrogen atoms form a single covalent bond to the oxygen, all 3 atoms fulfilling their goal of filling their valence shell and the water molecule being stable. Well, I hope this video clarified the process of forming covalent bonds through sharing pairs of electrons. And if you're asked to determine whether atoms are held together by covalent or ionic bonds, The best place to start is drawing out those electron configurations, looking at all atoms involved, and really determining how each atom can associate with one another with the goal of completing that octet rule, filling everyone's valence shell.